Hello, good day everyone. This is Tevs. Welcome back to this channel. This next repair is a 50-inch Devant smart LED TV, model 50UHD202. Not turning on and no standby light indicator. I will show you how to fix it. If you are interested in electronics and want to learn how to repair TVs and other electronic gadgets, you came to the right channel. So be sure to like, subscribe, and ring the notification bell so you never miss a video like this. So, let's get started.
The main power supply has a 2-resistor burn. This is probably the reason why it is not turning on. The customer reported that the TV was exposed to rainwater and it was plugged in at that time. I'm sure that the resistors are not the only defective ones. It's also this power MOSFET. The MOSFET is shorted. And the PWM driver IC may also be dead. The VCC of the PWM driver is shorted, or the Zener diode across the VCC line is shorted. Also, the optocoupler line is shorted and has a Zener diode. If the MOSFET shorts, the resistor burns, and it will be open. Because the MOSFET is shorted, the source becomes 350 volts, and the current sense also becomes 350 volts. And the PWM will also be damaged due to the high voltage. Looks like the rectifier diodes are okay, but the AC main fuse is blown, and it's doing its job. The current sense resistor going to the PWM driver is burnt. Also, some resistor on the source to gate has burned. The PWM driver IC won't survive in this situation.
Let's apply flux to the power MOSFET and remove it. It is hard to remove the MOSFET because the surface of this solder pad serves as a heat sink for the MOSFET.
The MOSFET finally desoldered. Let's also remove the burnt resistor. Let's clean the board using paint thinner. We can replace the MOSFET, any part number that came from a PWM-driven power supply. but we don't know the resistance value of those tiny resistors that are burnt. So we will modify it using STRW6053N.
STRW6053N, wattage is about 90 watts. It can handle it up to a 55-inch LED TV. Many videos of this modification that I uploaded to this channel. Some say, why not use CA888? CA888 has no official manufacturer datasheet. We don't know how many watts it can handle. I'm not saying CA888 is not good. They are similar connections and easy to use. But I go with STRW6053N.
Let's prepare the pins of the chip and connect them to their assigned connections. Let's first connect pin 3 to the source solder pad of the original MOSFET.
Next, pin 1 will be soldered to the drain of the solder pad of the MOSFET. Pin 1 is the drain of the STRW6053N. Pins 5 and 7 will be soldered together and will be connected to the negative or ground later. Let's solder wires to the remaining pins and connect them to their specific connections later. Red wire to pin 4, which is the VCC of the chip. White wire to pin 6, which is the feedback of the STRW6053N. Blue wire to pin 5 and 7, which is the ground or negative.
The PWM driver is defective. It must be removed to avoid disrupting the optocoupler line and the VCC supply. The Zener connected to the VCC line is shorted. It must be removed. Also, the Zener diode connected to the optocoupler should be removed.
Now let's connect the red wire. The positive terminal of this capacitor is connected to the VCC of the PWM drive, and it will be connected to pin 3 of the STRW6053N. VCC voltage is about 13 to 16 volts. Next, the white wire will connect to pin 4 of the optocoupler.
And the pin 5 of the STRW6053N is the feedback.
Let's remove the resistor and the Zener diode from the source to avoid disturbing the source line. Now let's replace the burnt resistors. The resistor's duty is for current sensing or overcurrent protection. The resistance value that we will replace is 0.33 ohms. The lower the resistance value, the higher the current needed to trigger the threshold for protection of the STRW6053N. The resistor is connected to the source and goes to the negative. Mostly, if the power MOSFET gets shorted, this resistor opens or burns. Sometimes the main fuse blows first, and the resistor won't burn. And the PWM driver IC won't get damaged.
Thank you to our latest members and those who continue to support this channel. We greatly appreciate your membership. God bless you all.
Now let's connect pins 5 and 7 to negative or ground. All pins that need to be connected are now connected. We will not yet replace the main fuse. We will solder this 220 ohms, 20 watts resistor to the solder pad of the main fuse for a safe test if the power modification is working or not.
You can use an incandescent bulb with this method. Now let's try to see if we have a voltage output. We can measure the voltage at the positive terminal of these electrolytic capacitors. Negative probe to ground, and the positive probe on the positive terminal of the electrolytic capacitor.
We have an output voltage now of 12.1 volts. The voltage is still present, even if it was unplugged, which means the power modification is working, and no problem.
Let's place the main board back, connect the LED backlight and the panel, and see if it will work. Let's try with the resistor still on the fuse line. No image appears, and no backlight. Seems like the power modification shut off because the 220 ohms resistor is still connected to the fuse line. Let's remove the resistor and replace a fuse.
There is no fuse holder, so we will solder the fuse. The fuse rating is 4 ampere, 250 volts. The fuse is now soldered in place. Let's try it again and see if it will work. It's turning on now and has a display. The STRW6053N is not generating heat. If the chip generates heat in a short period of time, it means the STRW6053N can't handle it.
The chip probably gets hot when in long-term use, so we will drill a hole so that we can put a screw to hold the chip close to the surface of the PCB, and it will serve as a heatsink.
We will put an insulator so that the chips don't touch this trace because it's negative. Let's apply thermal paste. At least somehow the heat will transfer to the PCB.
The thermal paste helps the heat transfer to the PCB, even though the surface of the PCB is not a flat surface.
The hole is smaller than the screw, so it will screw into the PCB, and no need to put a nut on anymore. This copper is also connected to the other side and serves as a heatsink, which is the drain terminal of the power MOSFET.
Let's try it and see if there's no problem putting a screw or nothing gets shorts. The TV works, and it has been powered on for about 5 minutes now. Let's unplug it and see if the chip gets hot. Not hot. But, ouch. I was shocked because the screw is positive and the capacitor is still charged.
A few moments later.
The TV is now working great. That was an electrifying repair. Not harmful, but it's shocking. Thanks for watching. I hope you enjoyed it and learned something from this video. You can support this channel by liking and subscribing. Click the notification bell to stay updated. Once again, this is Tevs. See you again next time. Bye for now.